So in the last lesson, we learned about extraneous roots, and we kind of said, well, they happen. But now we're going to see a little bit more why they happen and how it connects to the graphs of x squared and square root of x and how they're different. So we're going to go to a handout that I gave in class. You can just look along if you're at home watching the video, get it from me a different day. See pages 1 and 2 of the handout, using graphs to understand extraneous solutions. And we're going to fill in the steps and see why this happens. So we're switching over to this handout now. And I'm going to actually zoom out a little bit on this so that we can see the full process together. So it's going to be a little small, but hopefully you have the handout. So here I have a square root equation, and we know we can graph both sides of an equation to see a solution. So right now, I can see, remember this equation only has x's in it, that the answer should just be x equals 1. So we're going to go through solving this equation. You can see right here I have what I graphed. So the first thing I would do here is I would add 6 to both sides. And I would get the square root of x plus 3 equals x plus 1. Okay. So now I'm graphing both of those. Because I've changed the graphs, we moved the graphs, but we still just have an answer of 1. Okay. Now the next thing I would do in this equation is square both sides. So that's going to give me, on this side, x plus 3. This is x plus 1 times x plus 1. So I'm going to write down here, if I multiply this out, that's x squared plus 1x plus 1x is 2x plus 1. So now, in this section, we see both of these are graphed. Now here's where the interesting thing happens. Because this function is a square root function, we only have that like half of a sideways parabola. When I change the equation and I square both sides, I created a whole x squared parabola because I have a quadratic now. So we went from just having an answer of 1 to still having an answer of 1, but also having an answer of -2, which isn't the answer to the original equation, and there's my extraneous root. And if I go through and solve this, right, I'd subtract so I get x squared plus 1x minus 2, and I can go through and solve, and I get 1, which is the answer I want, and -2, which is the answer that's extra. And this is a good picture of what happens with a quadratic, right? When we set it equal to 0, we notice we still have the same answers as before, we've just moved them down to the x-axis. So this is extraneous. If we checked it, remember, only the answer to my original equation is the answer to the actual equation, and it has to do with the difference in those graphs. So we're going to look at another example on the next page. And this one, we see that just barely the original problem does have 2 answers. So I'm going to zoom in a little more just to see what those 2 answers are. And read my graph. So it looks like we have an answer of -3 and -5. Remember, I'm ignoring the y's because my original equation doesn't have any y's in it. So on this one, I showed less steps, just because we're getting the basic idea. So this one has 2 answers. The next thing I would do is square both sides. So I get 2x plus 10 equals, I'm going to write this twice up here. So x squared, 5x, 5x, 10x, plus 25. And that is the next graph that I have down here. So I have 2x plus 10 and x squared plus 10x plus 25. And we see that we still, in this graph, have those same 2 answers of -3 and -5. So we didn't create any extraneous roots, because this square root graph is curved, so it is possible for it to intersect the line twice. It doesn't always, but it can. And then my next step in this equation would be to set it equal to 0, and we see that down here. If I set the equation equal to 0, I would get 8x plus 15 equals 0. You see the same 2 answers, right? And if I factor and solve, I get those 2 answers. and I checked them in the original, they would both work. So this is the idea of like where those extraneous roots come from. It really comes from the human decision to restrict the domain of the square root of x and make it a different shaped graph than x squared. We're going to connect this, so back in your packet it says now we're going to look at example 3. This is the reason that you have to remember the plus or minus. Okay, so now we're looking at a quadratic equation where we need 2 answers, but a square root function only gives us 1. Okay, so this is something from unit 2, but we're seeing how it kind of connects. So here I have both sides graphed, and I can tell, and this should be an equation we're familiar enough with, that we get answers of 3 and negative 3. So the next thing I would do, right, is add 9 to both sides and get x squared equals 9. Okay, and we see when we have x squared equals 9, we still have those same 2 answers. But then when I take a square root of both sides, because the square root function can only give 1 answer, it looks like I just get an answer of 3, which is what I see here. But I know my original equation has 2 answers, which is why I have to remember the plus or minus. So those 2 ideas, getting rid of answers and making sure we have both answers, come from the same type of graphing issue. So we're going to look at one more, which is kind of outside of what graphs you have to know for the course. And this is just a rational equation. And this is one of the equations that we had in your notes, okay, back on page 20. And we're not really going to focus on it that much. If you flip back to page 20 in your notes, you'll see that work we've done. And this is the crazy graphs that are rational function graphs, which you would do next year, but you don't really have to know about this year. So if I look here, I see that when I graph both sides of this, that I have an answer of, so we're going to come here, and it looks like, oh, here we go. I believe that answer is 8. So it's hard for me to tell exactly where it intersects, but this answer is 8. There are no other answers. The blue and the red don't cross. I'm going to tell you they don't cross up here, even if these are down. Now, when we go through this process, and if you looked back, we get rid of the denominators and we change the function from a rational function to a quadratic function that does not have restrictions. So we end up with 2 answers, one of them being negative 3. And negative 3 is a restriction to this equation, because this is x plus 3, x plus 5. Okay, so when we change that type of function and change the type of graph, that is also the reason that we get answers that don't work. You'll see another one. Here's another rational function from page 21. This one does have 2 answers, and when I make it into a quadratic function, I also have 2 answers. So if that felt kind of fast, that's just connecting that, hey, everything is a graph, right? And the graph should have the same solutions as algebra work, and that changes to graphs. The types of graphs we do as we do algebra steps are what gives us sometimes extra answers we have to cross out.